He hits it high. He hits it deep. It is out of here.
Baseball, America's favorite pastime, is not just a game of skill and strategy. It's also a game deeply rooted in the laws of physics. Today, we'll explore the science behind hitting a baseball and why it's one of the most challenging feats in sports. Let's start off with a pitch. In the MLB, pitchers usually throw pitches faster than 90 miles per hour. In our case, we will say the pitch is thrown 100 miles per hour, which reaches the batter in 0.4 seconds or 400 milliseconds. It takes 100 milliseconds for our brain to process the image, 25 for our brain to send the signal to swing the bat, and 150 milliseconds to complete the swing. This means that a batter has only 125 milliseconds to process whether to hit the ball or not. If they are even 10 milliseconds too early or late, they will miss the ball entirely or foul it off. Now, if the ball is hittable, the batter must generate a large amount of force to try and hit a home run. This can be calculated with our kinematics equation of velocity to find the acceleration, along with the Newton's second law of motion. We can use the equation force equals mass times acceleration and plug in the mass of the baseball along with the calculated acceleration to get the force needed to hit a home run. On average, the force required to hit a home run is 18,439 newtons, or 4,124 pounds of force from the batter. This is no easy feat, and which is why baseball players bulk up to generate force in their swings. Another concept of physics that determines the force transmitted from the bat to the ball is momentum and impulse. The momentum of the bat and ball is found by multiplying the mass and velocity. Momentum tells us the motion of the ball. The change in momentum is found by the force applied on the ball over a period of time and is called the impulse. Impulse is found by multiplying the force by the time. This is why coaches tell players to follow through with their swings to increase the amount of time that the bat is hitting the ball, generating a higher impulse and more momentum. Usually, the bat touches the ball for 0.7 milliseconds, but sometimes a batter wants to bunt the ball and hit it short, which is why they try to reduce the collision time and lower the impulse, slowing the change of velocity. Finally, the angular velocity, which represents how quickly an object rotates around an axis, affects the trajectory of the ball. The greater the angular velocity of the ball after impact, the faster it will spin and the more distance it is likely to travel. This angular velocity depends on the point of contact on the baseball. The most optimal point of contact for the highest angular velocity is 4 to 7 inches from the top of the bat, also called the sweet spot. This sweet spot allows for the most amount of force as well as the least amount of vibration felt on the hitter. So hitting a baseball is a lot more scientific than most people really think. Batters indirectly take into account the velocity of a pitch, force of their swing, the momentum and impulse of collision, and the angular velocity of the ball after collision to hit the home run.